Hey everybody, we have question 10.4 here in this video. So we have some true-false statements regarding intermolecular forces that we need to go through and make statements regarding their validity. So we've got these 5 statements, and then we have some important information up here. So each of the bullets corresponds to one of our statements. So for statement 1, this says as the polarity of a covalent compound increases, the solubility of the compound in CCl4 also increases. CCl4 is a nonpolar compound. So this statement is saying that as a compound becomes more polar, it will become more soluble in a nonpolar substance. We know from lecture that like dissolves like in terms of dissolutions. So that means polar compounds dissolve in polar solutions. So this statement is going to be a false statement. If it were to read true, it would say that as the polarity of a covalent compound increases, the solubility of the compound in CCl4 decreases. So that solubility should go down as your compound becomes more polar because we're dealing with a nonpolar solution. For statement 2, they say that NH3 will have a lower vapor pressure at negative 50 degrees Celsius than NO. So the temperature here isn't exactly relevant. As long as both of these compounds are at the same temperature, then we can ignore the value of temperature and we can just focus on the intermolecular forces that are present in each of these compounds. So what we want to do here for vapor pressure, we just want to choose whichever compound has the stronger intermolecular forces. Whichever compound has stronger IMFs, those particles are going to be more attracted to one another, and they're going to be less likely to leave the liquid phase and enter the gas phase. If we think about the intermolecular forces present in each of these compounds, NH3 exhibits hydrogen bonding. NO exhibits dipole-dipole intermolecular forces. Hydrogen bonding is stronger than dipole-dipole, which means that NH3 has stronger intermolecular forces, meaning that its particles stick together more tightly, or they're more attracted to one another. So if we had 2 samples of liquid, NH3 and NO, the NH3 particles are better attracted to one another, so they're not going to be as likely to separate and turn into the gas phase. The NO particles, however, they have weaker intermolecular forces, so it's going to require less energy to separate that NO liquid particles and turn them into the gas phase. So we're going to have a higher vapor pressure for NO and have a lower vapor pressure for NH3. So this is a true statement right here. For statement 3, it says that chlorine will have a higher melting point than HBr. So now we need to look at the intermolecular forces present. And our bullet advice here says that the strongest intermolecular forces are going to have the highest melting point. If we think about the IMFs present in both of these, chlorine is a diatomic gas. This is going to be a nonpolar compound that will only exhibit London dispersion forces. HBr, however, is a polar compound that will exhibit dipole-dipole intermolecular forces. That means that HBr is going to have stronger intermolecular forces than Cl2. Because HBr has stronger intermolecular forces, it also should have a higher melting point. So this is going to be a false statement. Cl2 should have a lower melting point than HBr. For our 4th statement, it says that Cl2 will have a higher boiling point than argon. So now we just need to again consider our intermolecular forces. The strongest intermolecular force is going to have the highest boiling point. Diatomic chlorine gas is a nonpolar compound that only contains London dispersion force. Argon is a monatomic gas that also is nonpolar, meaning it only exhibits London dispersion force. Because each of these only exhibit London dispersion force, we're going to have to compare the molar masses of each of the species. The molar mass of chlorine gas is approximately 70 grams per mole, and the molar mass of monatomic argon is approximately 40 grams per mole. That means that chlorine has a higher molar mass, thus has stronger London dispersion force, and stronger intermolecular forces overall. If we have stronger IMFs, then we'll have a higher boiling point, making this a true statement. Our last statement up states that HF will have a higher vapor pressure at 25 degrees Celsius than KCl. So now we just need to look at our advice, and it says that whichever compound has the higher vapor pressure is going to have weaker intermolecular forces. So we just need to consider the intermolecular forces present in each of these compounds. If we look at HF and we look at the Lewis structure, we have hydrogen bound to fluorine, and the fluorine has 3 lone pairs surrounding it. HF exhibits hydrogen bonding. That's a strong type of intermolecular force. If we think about the Lewis structure for KCl, this is going to be an ionic compound, which means this compound, KCl, exhibits ion dipole intermolecular forces. Ion dipole intermolecular forces are stronger than hydrogen bonding. Because the intermolecular forces in KCl are stronger, that means that HF should have a higher vapor pressure. Because HF has weaker IMFs, so it's more likely for the particles of HF to leave the liquid phase and enter the gas phase. So this last one is going to be a true statement. And just to reinforce all of those again, so our first one was false. Our polarity, as the polarity of our compound increases, the solubility of the compound in a non-polar solvent like CCl4 should decrease. NH3 exhibits hydrogen bonding, so it has stronger IMFs, and therefore it should have a lower vapor pressure than NO, which only has dipole-dipole. Statement 3 is false because chlorine should have a lower melting point than HBr. Chlorine only has London dispersion force. HBr has dipole-dipole. For statement 4, this is a true statement. Chlorine has an atomic mass of 70 grams per mole. And then argon has a molar mass of 40 grams per mole. So we have stronger London dispersion force for chlorine. Therefore, we should have a higher boiling point. For our fifth statement, this is also going to be true. It says that HF will have a higher vapor pressure at 25 Celsius than KCl. HF has weaker intermolecular forces. It exhibits hydrogen bonding, whereas KCl exhibits ion dipole intermolecular force. The lower strength intermolecular forces of HF are going to result in a higher vapor pressure for HF, and that's why this statement is true.